Alright, let's look at the ODE practice exam 4, problem number 11. Alright, so we want to find the coefficient C2, C3, and C4. Alright, so looking at the initial value condition, we can see that y of 0 is equal to 1. So this tells you that C0 is going to be equal to 1. Right? And y prime of 0 is equal to 2, which tells you that C1 is equal to 2. Right? Then let's look at the differential equation here. Alright, so y double prime, so power series for that would be summation n goes from 2 to infinity. Then this is a second derivative, so it's going to be n times n minus 1 times c sub n x to the n minus 2. Alright, then, before that, maybe I'll do the, I move everything onto the left-hand side. So it's going to be subtracting xy. So you have y double prime minus xy is equal to 0. Alright, so this is going to be minus x times, alright, y is a summation, n goes from 0 to infinity, cn x to the n, right? And this is equal to 0. Right? So I'm going to incorporate this guy, x, in here, right? So that we can just make it n plus 1, right? Right, then here's what we're going to do. I would like to have nth power here and nth power there. I'm trying to get that. Alright, so let's see. So the way we get that would be, I'm going to write this guy as, summation. I'm going to start from 1, and infinity, Then since I'm shifting the index by 1, so increasing the starting number by 1, so I'm going to decrease the indices by 1. So you have a c n minus 1, then you have a x to the n instead of n plus 1. Alright, so there's a negative sign here. Alright, so we're going to do the same thing here. A little bit, it's kind of the other way around. I want to have nth power here. So instead of starting from 2, I'm going to start from 0. Right? Since I decrease the starting number by 2, I have to change the indices, increase the indices by 2. So n becomes n plus 2. And n minus 1 becomes n plus 1. Then you have a cn plus 2 times x to the n. Right? So I'm increasing all the indices by 2. Right? So this is equal to 0. Right? Unfortunately, this one starts from 1, this one starts from 0. So what I'm going to do is I'm going to pull the very first term when n equals 0 from the first summation. Which is going to be, so when n equals 0, it's going to be 2 times 1, c2, and x to the 0 is 1. So it's going to be 2c2. So we have 2c2. Alright, that way we can just start from 1. So you have a summation, n goes from 1 to infinity. Right, now we have the same thing here, and so we have the same thing here. So we can just combine those summations. Right, so we have x to the n in common, right here and there. Right, then I'm going to just put x to the n, maybe right here. All right, then what you get is quantity n plus 2 times quantity n plus 1 times Cn plus 2. Then you have a minus. Let's say I need a little bit more room here. Let's see. All right, I'm going to just erase that. All right, so I'm going to have Cn plus 2 minus Cn minus 1. Then we have x to the n equals 0. All right, so we need to make sure that all the coefficient will be 0. So here, what we're going to do is here, I'm going to set this guy. So this is equal to 0. And then we set, we set this guy equal to 0. All right. So here are the conditions. So we're going to get, first thing we get is here. It looks like C2 must be 0. All right. And here, I'm going to solve this for Cn plus 2. So Cn plus 2 is equal to Cn minus 1 over n plus 2 times n plus 1, right? So we got the C2. So C2 value is right here. So I'm going to just box it out, right? So we got, so that's not what I want. All right, so here is the C2 value. We found 1. All right, so let's find C3 and C4. All right, so we can use this second formula here. So in order to find the C3, I'm going to put the n equals 1. So if you put, let's see, n equals 1, all right? If you put n equals 1, all right, that's going to give us, all right? So I'm going to use the formula here. C3 is equal to, here's a 1, so it's going to be C0 over, right, so n equals 1, so 3 times 2. Right, so which is equal to, right, C0, we know that it's 1, so it's 1 over 3 times 2 is 6. Right, so we have, I'm going to just say C3 is equal to 1/6. Right, so I'm going to just box that out. Right, so here, right, so we got the C3 value. All right, then we can do the same thing. We can just set n equals 2 to find C4 value. So C4 is going to be equal to, right, C2 minus 1, where C1 is over. All right, so 2 plus 2 is 4, 2 plus 1 is 3, so we have that. Then C1 is 2, so it's a 2 over 12, which means that actually C4 happens to be the same as a C3, but you get 1/6. All right, so we have C4 value there. All right, that's all we need to find, right? All right, that's it. I hope that this was clear.